So inverse variations, graphs of inverse variations are curves. Approach which do not cross through either axis and curve downward as you move to the right along the x-axis. So I'll show you an example of that. So if you wanted to see a rough example of what an inverse variation graph is going to look like, your y-axis and x-axis and the like that. So in general, all inverse variations are expressed by the formula y is equal to k over x. So here's an example for you. So t-shirt company tracks the number of t-shirts it sells at different prices. So the higher the price of the t-shirt, the less t-shirts they sell. The lower the price of the t-shirt, the more t-shirts they sell. So we decided that the dependent variable was the number of shirts sold, and the independent variable was the cost of the shirt, price point of the shirt. So you need to put that on the graph here. All right, so now that we have an appropriate scale, we can plot all of those points that we saw and then get the line of best fit. So there are the points on the line, on the graph. Now we join them with a line. Line red. So find the constant of variation and express the relation as a formula. So now you've got your formula, you've got all your variables set. So now you can, stop laughing at me. Now you can substitute any pair of values from the original chart and solve for k. So which two values do you want to use? Sorry? 40 and 1,000? Okay. So we have 1,000 shirts is equal to k over $40. Solve for k. So you multiply both sides by 40 and you get k is equal to 40,000. And that is our constant of variation. Now that looks like a really big number for a constant. All the other ones we've been dealing with have been like 2 or single-digit numbers for the most part. But that's okay. Constants can be really big numbers as well. And that is that. So now we can actually write out the formula. So you've got y is equal to 40,000 over x. Notice I used these variables because we weren't assigned any in the example. At least I don't think we were. So now we can figure out, well, what would happen if how many shirts am I going to sell if I price my t-shirts at $100 a shirt? And you can substitute that price point into here, and you can see, well, if I put them at $100, I'm going to sell how many shirts? 400. Not good. So you can see what the relationship. If I price them at $1, then you can see how many shirts you're going to sell then. So it allows you to kind of analyze the relationship. So here's your assignment, page 322, questions 1 to 8. Next class, we will go over the homework from last class on direct squared variations and this. Okay.